solve some other Leetcode problems. So now that's going to be the 1676 lowest common ancestor of binary tree 4. So for solving this problem, I suggest to solve the previous 3 problems, because all the previous problems that are going to be the basis to solve such problem. Yeah. So the only difference is that we're going to have a node array, and we're going to check the lowest common ancestor of this node array. So for example, this is 487, so the lowest common ancestor is going to be 2. And for the second one, the node is going to only be 1, so it's going to be itself 1. And for this one, 7, 6, 2, and 4, this is 7, 6, 2, and 4, so the lowest common ancestor is going to be 5. So there's going to be no difference to other lowest common ancestor problems, but normally we can solve the 2 nodes easily. So for example, if we just want to solve the 6 and 7, it's going to be okay, we can find 5. If we can find 5, we're going to compare this 5 maybe with 2, and it's going to be 5 itself. Now we're going to compare this 5 with 4, it's going to still be 5, so we're going to return 5. As you can see, this is going to be O(n) squared times complexity to solve the problems. Yeah. So first of all, let's define a DFS. So for this DFS, it's going to be the like lowest common ancestor 1 problem. So for that problem, we just need to put a node inside with P and Q. And P and Q are 2 nodes. Yeah, because we cannot solve all the nodes together, but we can solve each time we can find 2 nodes, what is their lowest common ancestor, and then we're gonna use that node to continue. To continue the task. Finally, we can get the answer. Now let's just finish the coding for this one. So if node inside TQ, so I'm gonna return the node. If a node not exists, so I'm gonna return a none. Now I'm gonna prepare a left and right, and gonna be the DFS not dot left with P and Q. And similarly for the right, I'm gonna use the not dot right with P and Q. Yeah. So now I want to check if the left and right both exist. So if they both exist, so I can return the node itself. Otherwise, I'm gonna check if left or right exist. So I'm gonna return the left or the right. Yeah, because those 2 nodes always exist, because it is set according to the question. So all the nodes will exist in the tree, and all values of the tree's nodes are unique. So this is why we can solve it like that. Yeah, and let's just check the constraints. So the node dot val are unique, and not I will exist, and not I are distinct. So that is helpful for us to solve the problem. Yeah, but only we don't know the length of the nodes array, but the maximum can be 10 to the power of 4. So this means by using n squared, we might pass for this kind of problem. Yeah. Now this is the DFS. Now we can start to check 2 by 2. Yeah. So I'm going to prepare a result. It's going to be the nodes array from 0. And then I'm going to use I check, so for I in range from 1 to the length of the nodes array. So I'm going to check 2 by 2. So the result is going to be the DFS with the root node, and with the result, the first node and the second node, it's going to be the node I. So for each of the time, this result is going to record the node as I explained before. So for this example, first 6 and 7, so the lowest common ancestor is going to be 5, and then 5 is going to compare to 2, and then 5 is going to compare to 4, and finally I'm going to return this 5. So finally I can return the result. It's going to be the lowest common ancestor. Now let me just run it. As you can see, it works. Now let me just submit it. As you can see, it passed all testing cases, although it is slow, but at least we can pass. And this is the O(n) squared solution. Thank you for watching. See you next time.